Hello everyone, in this video we're going to talk about literal equations. I'll first start by defining what a literal equation is. So a literal equation is an equation involving two or more variables. In the last couple of videos, we've been dealing with the distance, rate, and time formula, particularly when we have distance equal to rate times time. Formulas like this one in particular are special types of literal equations. And in order to transform a literal equation, you solve for one variable in terms of the others. Here we have distance in terms of rate and time. So what this means is we want to get the variable that we are solving for alone on one side of the equation. Here that would be distance. But let's say I wanted to solve for time instead. So now I want to have t equal to some other stuff. Here's what we do. If we want to have a literal equation where it says solve for this particular variable, we're going to have, in this case, t equals some stuff. So what we got to do first is look at the formula that we're starting with, and then look how we're going to isolate the variable to get what we want on one side equal to whatever's going to end up on the other side. So in order to do this, we're going to solve for t, and we're just going to divide by r. The r's cancel out here, and we'll get t equal to d over r. So if we're working with that distance, rate, and time formula, and we want to solve for time, we'll just do distance divided by rate. And likewise, if I wanted to solve for rate, I'll just do that over here real quick. All we would do is divide by t. So a very similar approach. I would have rate equal to distance over time, and that would solve this literal equation. This is just one example. I'm going to work out a couple others. Here we have the area of a triangle, which is a is equal to 1/2 base times height, and here we're told to solve for height, for h. So in order to do so, we're going to have h equals stuff. That's going to be our little template for this particular example. Right off the bat, I see that I have 1/2 times b times h. Let's get rid of this coefficient first, and because this is a half, what we're going to do is we're going to multiply both sides by 2. You can divide by 1/2. It does look a little messy, but to make it a little easier on ourselves, what we're going to do is multiply by 2 to both sides of the equation, and we'll get 2a equal to base times height. And then last thing we got to do is divide by b. Just like our template, we have h equals stuff. Here we have h equal to 2a divided by b, just like this. Let's work out one more. The interesting thing about this one is that it's all just variables. For this particular example, we're having a times b minus d equals c, and it says to solve for b. So our template says we want b equal to some stuff. Let's see what we can muster here. Here's b. I want to get this by itself. So what I'm going to do first is add d to both sides. I have a times b equal to c plus d. Last thing we do is divide by a. Ideally, what you're going to do is divide the entire right side by a rather than dividing each individual term. It just looks a little bit cleaner that way. So now we got b equal to c plus d divided by a. The main purpose of these literal equations is if we're ever in geometry, this is just an example, if we're in geometry and we're given the formula for a particular area, surface area, or volume, but it says to find a different part of that figure we're working with, like find the height, or find the length, find the width, things like that. These would be a good tool to reference when we're trying to find that particular dimension. Thank you so much for watching, and I will see you later.